Okay, thanks. So I will pass the word here for Adriano, which works with us since last year also. And well, Adriano and friends as well is going to present tonight. If anyone has any question, do not hesitate. Go ahead with the chat, of course. But if you want, we have only 19 people. Uh, this would be perfectly if you want to open the mic and start questioning. I believe there will be a Q&A session in the end, so the questions can be addressed over there. But you don't need to wait to ask if you need it. Okay, so please, Adriano.
Okay, so good night, everyone. We are starting the presentation of the Rocket Pi Hackathon 2022. And we'll start this presentation by giving you some information about what is Rocket Pi and how the Rocket Pi works, to give you some context about what we will be doing these next days. And then we will present the Rocket Pi Hackathon 2022 itself and some prizes. Wait for that. And so, with no further ado, friends, you can start.
I think the screen is not sharing. Is it just me?
Yeah, it's not sharing currently. Who is going to share, Adriano or friends? If you need, I can share as well.
Yes, I can share. Just a
Okay,
minute.
thank you, friends.
Uh, all right. So in fact, Gui, can you share? Because my computer is
Sure, no
a little
problem.
bit slow.
And you just say to me when you need
Okay,
to pass the
just sharing.
slide.
Okay, here. I can do this, okay? It's no problem for me. So you can go, friends.
Okay, so uh, I'll start talking about what is Rocket Pi. So Rocket Pi is basically the next generation trajectory simulation solution for high power rocketry. This basically means it's a pretty complete and advanced rocket simulator. It's a Python library and an open source code, so you can all easily access it through GitHub. Going a little further, we are also a 6 degree of freedom simulator with variable mass effects, both features that we find essential for a good simulator, rocket simulator. And also we are a model with 98% adherence. Uh, Going further, uh, I'm going to show you a little bit about our most recent achievement. So first of all, we were able to implement a long-awaited feature that is the integration of rocket trajectory to Google Earth, as you can see here. So now anyone can simulate the trajectory and plot it on Google Earth and create beautiful images like this one. Also, we had a partnership with the ESRA to create a weather analysis for the SA Cup 2022. And also, we published a paper about Rocket Pi on the 21st Python Science Conference, the SciPy conference. So as you can see, we are always listening to the demands of the rocketry community, and we are eager to help in any way and in any front as possible. So now I'm going to show you a little bit more about how Rocket Pi works. So here you can see the main architecture of the code. So we have, as you can see, four main classes. the solid motor, rocket, and the environment that are where the data are mainly initialized. And then we have the flight class, that is where the simulation really happens. So going one by one, we have first of all the environment class. That is the first one you will you will declare in the simulation. Here we are going to create the Earth atmospheric and wind models. So here we are going to put the parameters such as latitude, longitude, time, and height, for example. Create all the atmosphere for the flight. Then we have the solid motor class. That's the second parameter we create for the simulation. Second class object we create. So here you will put the nose profile, grain parameters, burnout time, thrust curve, and so on. And finally, we can put the solid motor on the rocket. So in the rocket class, you're going to build the rocket itself. So add the aerodynamical parameters, mass and inertia, add fins, parachute, nose cone, and so on. And finally, now you create the flight, and here the magic begins. The simulation begins, and in less than 1 second, the flight is run. And no, sorry, and in 1 second, we calculate all positions, velocities, and acceleration vectors. And the interesting thing to point here is that we divide this way not because it's intuitive, but also because it's easy. It facilitates the development of new features. So if you have a new feature about in motors, you can easily go to solid motor and enrich the class. So next one. So as I have shown and said, here we have some of our main functionalities. So the whole rocket trajectory is described, and you can also see this on Google Earth that I think is amazing. The results in less than 1 second, so it's especially useful, this information, for the dispersion simulations. And RocketPy has a great flexibility for running different scenarios. So different environments, we can create an environment that is in fact an average environment. We can we can have parachute with 5, 10. We can create a rocket with 5, 10 parachutes and so on. It's a very flexible software. Going on, we have now what validates our software. So first of all, we have already published a paper. Its name is here, RocketPy 6 Degree of Freedom Rocket Trajectory Simulator. And here you can see the dispersion working. And more than that, we also have empirical validation, as you can see. So here are some of the rockets we simulated and then launched. And if you can compare here, the relative error is incredibly small, especially with the Bellaloy and DRT launch vehicle. So the apogee, we are only showing the apogee, but you could get any parameter. It would still have a pretty small error. So the point here is that we have both theoretical and empirical validation for this software.
Okay, so thank you, Franz, for enlightening everyone about what RocketPy does. And we, of course, invite you to see our GitHub. There are some examples of code there and further explanation of what RocketPy does. So now for the main event of the night, we will present to you the RocketPy Hackathon 2022. And first of all, some general informations. So if you are here, you probably have filled an interest form, and now you ask you to fill an registration form. That form is very important for us to dimension our event, and also for registering your teams, which we will talk more about a little bit later. And as you can see, the main event will occur between 26th and 28th of August, and the results will be delivered until the 4th of September. The start of the event will be done in a kickoff meeting at 22 UTC at the day 26th of August. We may change this Google Meet to an Discord meeting, but we will be you will heard about that if you do so. And the closing session will be in August 28th at 22 UTC. So you have these 2 days for developing the task we will propose to you. Finally, about the main event, the one where we will be programming, solving problems about Rocket Pi. After we kick off, you may start doing the tasks. And if you don't have a team already, we will find a team for you. We'll help you finding a team. And the main communication way of doing we will have is Discord. So we do basically all of our communications and the interactions between teams, and also the uh, the mentors, and will be done by Discord. So you can do the hackathon by yourself, but we really encourage you to form teams. Some things to keep in mind when forming a team are things like time zone, preferable speaking language, and the maximum of 4 participants per team that we have established. And of course, we will be in Discord joining you together if you don't have a team. So the mentors will be provided for helping everyone with tasks, specific topics in Rocket Pi, and to commit your projects in GitHub. And the mentors will also be responding specific questions regarding any task in GitHub. More about the tasks, we will provide the tasks in a forked repository of Rocket Pi, where there will be issues with the tasks, with the descriptions of the tasks, and also their level of difficulty that I will talk more about later. And if you want any idea, you may look at the issues we have in our repository now. That will give you a hint about what's the direction the tasks are going to be. So as I said, the tasks will vary in difficulty. So we will have 3 levels of difficulties: easy, medium, and hard. And every level will have different punctuations. So 10 points for easy tasks, 25 points for medium tasks, and 50 points for hard tasks. We also may give you a 20% plus for ingenious solutions, and also penalties if you have a poor documentation. And your code will be evaluated, of course, by the code's capacity to solve the problem, but also the code documentation and reliability, and also efficiency of this proposed solution. And that may also be correspond to a plus point for you. So now for the price, one of the most weighted parts of this hackathon, we will distribute to you $200 in prizes, $100 for the first placed team, $6 for the second place team, and $40 for the third place team. The classification of the teams will of course be done by the summing the points of the done tasks, and we will have a special prize for the most innovative teams, where we'll give a Kerbal Space program. So I think about the hackathon. That's it. That's the QR code for the registration. No, the registration form. You may I will leave this in the window for you to scan this QR code and start filling it. And now we can open for questions for everyone.
I have a question.
Go on,
So,
please.
are the tasks going to be modifications to RocketPi, or what will the tasks be exactly?
Go on, Giovanni.
So we have a lot of tasks already planned. I think the number is almost close to 100, and there's going to be a lot of variety. So some of them will be modifications, code additions, bug fixes to RocketPi. Others will be more related to implementing something that works with RocketPi. So similar to implementing something related to machine learning or control that uses RocketPi to accomplish a goal on top of some other separate code. And others can be even I can review too much because of the challenges, but others are aren't related to, let's say, modifying RocketPi code base, but using RocketPi towards other goals. So there's a lot of variety, and there are even some tasks that don't require coding at all. Does that
That
answer your
answers my
question?
question.
Okay,
Yes.
perfect. Thank you.
Thank you.
Okay, so any more other questions?
I can ask another question. So we'll basically be doing as many tasks as we can in the allotted time. And so the largest number of points earned by a team will be the team that gets first place. Okay,
Exactly.
that makes sense.
That's perfect. So the
Yeah,
whole
and
idea is
usually
that,
go on.
sorry, go ahead, Adriano.
You will need to take into account that some tasks are more valuable than other tasks, so you have to balance that during the 2 days you have to do that.
And it's important to keep in mind that tests will be submitted and then they'll be evaluated so that we decide if the task was completed appropriately, so it gets the full points or not. And as mentioned before during the presentation, some groups may even get bonus points depending on the execution of the task.
Yes, I think this is something to that is important to make clear that a task will only be validated. You only will get points for tasks involving coding if the code works. So if it's not running, for example, so it's gonna be a zero. So it must be working, and then we are going to count out the all the points. And yes, it's just as simple. So the one with the most points is going to win.
Any further questions? Keep in mind that if you do not have a microphone, you may use the chat. And if you have more questions as well, Sullivan, go ahead. Don't hesitate.
Yeah, I will also be leaving here some QR codes for our repository, LinkedIn, and Discord. So if you have some questions after this meeting, you can please send them for us in Discord. Okay, so uh, I think we can call it the meeting if no one has any further questions.
Yeah,
I have
sure.
another question.
Oh,
Okay,
please,
please go
Ivan.
on.
Yeah,
So this is more about Rocket Pie itself. Earlier in the presentation, you said that it has 98% adherence, but I'm not familiar with what that means exactly. So if you could explain more about that.
sure. I guess we have a little chart, a little table, right, Adriano, if you could. So basically, when you say about the 98 adherence, is actually okay here. Once we have validated the Rocket Pi simulations, when we, of course, we tested against the simulation results against experimental data, we saw generally relative errors of the order of 2% when comparing the apogee of the rocket simulated against the actual apogee. The reason of why it's important measuring only the apogee instead of the whole trajectory is for a basically reason, which is that most of the rocketry competitions around the world have the challenges with the intent of achieving specific targets apogees. So once you are designing your rocket, predicting and forecasting correctly the apogee is of utmost importance in order to get more points on the competition. So basically, when you say, "Oh, this has 98% of adherences," what we are trying to say is that by using Rocketpy, you can base it on the examples, have mostly 98% of chance of getting close to your target apogee in the end. Okay, please, Breno, if you want to.
I've got the paper with the graphs. Can I? Uh, I forgot
Yeah,
the word. Mirror it
yeah,
another time.
present. Yeah, you can present. But for you presenting, I think Adriano will, stop presenting his screen. Yeah. But Sullivan, does it address your question partially or totally?
Yeah. So the adherence is basically the opposite of error.
Yeah, yeah. In this case,
And it's important to keep in mind that Rocket Pi is as accurate as your inputs, right? So if you do not have a reliable thrust curve or drag coefficients or rocket mass, of course, you may get worse results, definitely.
That makes sense. Thank you.
okay. Thank you for the question. That's it. And just for everybody knowing, if in case you have any further questions during the week before the hackathon, even if you are watching the meeting records after the briefing session itself, you can always contact our team. We are on GitHub, we are on Discord, LinkedIn as well. And in the beginning, we presented a picture of the whole team, which you can get in contact. We will make sure that everyone is labeled on the Discord server, so you can find any member of our team easily. And I believe that's it. You can
Once
press
again,
just the end.
thank you everyone for coming.
Yeah. Thank you, everyone. It was pretty much excited because, well, we have people from all around the world, basically, and we got a question on our Google Forms asking where are you from, and the results are, well, amazing. The doc space seems broken. Yeah, I see it. I remember you said this on Discord. I thought that Patricky, which was one of the developers, solved that. As he is not present here, Giovanni is automatically the person that will questionate of why the doc space is broken still. Do you know, Giovanni, anything regarding that? Okay, latest.
Uh, I think the docs are passing, and I sent a link here. It seems to be working for me. What do you mean by broken?
Whenever I try to open the code reference tab here, all the different contents on that page don't load the content over here. So if you want, I can share my screen and show it to you guys.
Yeah, yeah, agree.
Okay,
Would be good.
I could
one
reproduce it.
moment.
Yeah, I could
Uh,
reproduce as well.
I can reproduce it here, so I guess there's no need to share the screen.
Yeah,
Uh,
sure.
I'll go
Okay,
ahead
okay.
and share a link to a version that is working to our Discord page as soon as I get it working correctly.
Okay,
There's
but
no.
we can guarantee we will fix this before the hackathon starts, the kickoff meeting. This should not be hard to solve, I guess. Okay, and thank you, Asat, for bringing this issue again for us. It means a lot to us. So if you do not have further questions and not further contents to be presenting, I'd like to thank you all for coming here tonight on the briefing sessions, and thank you if you are watching this later. I will wait you on the next weekend so we can go together and start learning on top of Rocket Pine Library. And I'm really looking forward for seeing new contents and new ideas, getting new insights from you guys. Uh, any contribution is valid. This is something we must keep in mind always. So thank you and have a good night.
Thank you.